Hello students, welcome to today's session of chemistry. As you all know, we have started studying fifth lesson of your syllabus, that is electrochemistry. As usual, before starting today's session, we will revise what we learned in the previous session. In the previous session, we learned about Nernst equation, that is dependence of cell potential on concentration. If the concentration is not as that of standard conditions, then how can we calculate EMF of a cell? That we learn by taking an example, and we got one equation, and that is Nernst equation. So, what is the Nernst equation to calculate cell potential? It is E cell equal to E0 cell minus 2.303 RT over NF log to the base 10 of concentration of C raised to C into concentration of D raised to D divided by concentration of A raised to A into concentration of B raised to B. And at 25 degrees Celsius, that is at 298 Kelvin, if we substitute the values of R and F in the equation, then we get E cell equal to E0 cell minus 0.0592 volt divided by N into log to the base 10 of concentration of C raised to C into concentration of D raised to D divided by concentration of A raised to A into concentration of B raised to B. And the same equation we can apply to calculate cell potential as well as calculation of single electrode potential. That we learn in detail. The equation is very important as far as exam is concerned. So both ways it can be asked in exam, to derive the equation as well as to calculate EMF or any other thing by using the equation. Now, in today's session, we are going to learn about thermodynamics of galvanic cells. That means we are going to relate electrochemistry with thermodynamics. Thermodynamics we studied before it, so we know very well some concepts and we are going to relate these with galvanic cells. The first concept which we are going to relate is Gibbs energy. Do you remember it? So, Gibbs energy of a cell reaction and cell potential can be related. For that, some important formulas are required. So, let us start with the electrical work done in a galvanic cell is the product of, we can say, electricity passed and the cell potential, or EMF or electrical work done is equal to amount of charge passed into cell potential. So, amount of charge passed, how can we calculate? Cell potential, we know it is EMF of cell, or E cell it is. Charge of 1 mole of electrons is F coulombs, or 1 Faraday we can say. 1 mole of electrons is equal to 1 F coulombs. And if the cell reaction involves more than 1 electron, that is suppose n moles of electrons, then we just have to multiply F by n. Hence, we get the amount of charge passed equal to n into F coulombs. And cell potential is E cell. Hence, electric work equal to NF into E cell. Under standard conditions, only we have to make some changes. And in 1878, W. Gibbs calculated electrical work done in galvanic cells is equal to the decrease in Gibbs energy. Decrease in Gibbs energy, how we denote? By minus delta Z. So, Gibbs found out that electric work done in galvanic cell is equal to minus delta G, in short we can say. Of what? Of the cell reaction. Hence, we can write that electric work equal to minus delta G. but we just got that electric work equal to NF into E cell. We can relate both of them. Then minus delta G will become N into F into E cell. Or just rearrange the equation, we get delta G equal to minus NF into E cell. It is equation number 5.27. We will require this afterwards. Under standard conditions, this equation, somewhat we change it. Where there is E cell, we will write E0 cell, and instead of delta G, we write delta Z0. And the same equation 5.27 becomes delta Z0 equal to minus N into F into E0 cell. 5.28, this equation. And this equation explains E0 cell is an intensive property. Do you know there are two types of properties, intensive properties and extensive properties? As this equation has both delta Z as well as E0 cell, out of these two, E0 cell is an intensive property, but delta Z0 is an extensive property. How? The property which depends, or its value, it depends on the amount of substance, that is called extensive property. And if the value does not changes, if we change the amount of substance, then it is called as intensive property because it is independent on the amount of substance. So, E0 cell is an intensive property. We will prove that from the delta Z0 itself. We know that delta Z0 is an extensive property because its value depends on the amount of substance. If the redox reaction taking place in a galvanic cell, if it is multiplied by 2, that the amounts of substances oxidized and reduced are doubled, and the delta Z0 value also doubles. And as it doubles, that means it depends on the quantity of substance, and hence it is extensive property. The moles of electrons transferred, that also doubles. Hence, the ratio E0 cell equal to minus delta Z0 over NF. The same equation 5.28 it is. Just we rearrange that. So that equation, it will become like this. We have to multiply both of them by 2. So delta Z0 is 2, number of moles is 2, and hence E0 cell. So by cancelling the common factor, we get del E0 cell equal to minus delta Z0 upon NF. That means E0 cell has no effect. The value of E0 cell has no effect if the amounts of substances are doubled. That means the value of E0 cell remains same. By multiplying the redox reaction by 2 or any other factor, it means E0 cell is independent of the amount of substance, and hence it is a intensive property. Understood? So, E0 cell is an intensive property, delta Z0 is the extensive property. Now, again, some points to remember. We are going to just revise thermodynamical part, the part from thermodynamics lesson. For chemical reaction to be spontaneous, delta Z0 or delta Z only we can say must be negative. Then only the given reaction is spontaneous. But we know in a galvanic cell, a spontaneous redox reaction takes place. That means delta Z equal to minus NF E cell is the equation we got, in which E cell must be positive. Then only delta G will become negative, and then only the reaction will be spontaneous. So, just we have related thermodynamical part or Gibbs energy with EMF of the cell. So, for the reaction to be spontaneous, if delta Z must be negative, then E cell must be positive. Remember this thing. Now, the next point we are going to learn about is standard cell potential and equilibrium constant. Standard cell potential, that is E0 cell. We are going to relate this with equilibrium constant. Do you remember equilibrium constant? For that, again, we have to go to thermodynamics. Now, the relation between standard Gibbs energy change, that is delta Z0, of a cell reaction and standard cell potential is given by equation 5.28. What is it? That is delta Z0 equal to minus NF into E0 cell. The relation is this. Now, in thermodynamics, we learned that the relation between standard Gibbs energy change of a chemical reaction and its equilibrium or constant is given in thermodynamics as delta Z0 equal to minus RT into ln K. What is K? It is equilibrium constant. And delta Z0 is the standard Gibbs energy change. And the relation between them is this. That is equation number 5.29. We have got equation number 5.28 as minus delta Z0 equal to NFE0 cell, or delta Z0 equal to minus NFE0 cell, we can say. So if we combine both the equations, then minus NFE0 cell equal to minus RT ln K, because both these equations are of standard Gibbs energy change. So as left side is same, we will just equate the right sides of both the equations. So this is what we got. Now rearrange the equation, we get E0 cell equal to RT divided by NF into ln K. And the same equation, if we want to change ln, that is log to the base E, to the log to the base 10, then we have to multiply by 2.303. And hence E0 cell equal to 2.303 RT over NF into log to the base 10 of K. So again substitute the values of R, temperature at 25 degrees Celsius, that is in Kelvin, it will become 298. A value of N, that changes every time, so we can't change that. F is Faraday, that is 96,500. So if we substitute all the values of 2.303 into 8.314 into 298 divided by 96,500, then the value we learned in Nernst equation, the value is 0.0592, and hence E0 cell equal to 0.0592 divided by N into log to the base 10 of K will be the relation between standard cell potential and equilibrium constant. Understood? Now, the time for assignment. The assignment for this time is question number 1. Using the relationship between delta Z0 of cell reaction and the standard cell potential associated with it, how will you show that the electrical potential, that is E0 cell, is an intensive property, the one which is independent of the quantity or the amount of substance? So you have to show that. Question number 2 is derive relation between standard cell potential and equilibrium constant. Standard cell potential E0 cell, equilibrium constant K, that is the relation E0 cell equal to 0.0592 upon N into log to the base 10 of K. The last relation we learned. But you have to give derivation. That means in detail, stepwise you have to go, and finally you have to prove the relation. Understood? So this is assignment for this time. Thank you.